Hello everybody, welcome to MS-DOSX. If you are in here from another class like CS10, you're very welcome to stay, but we do ask for zero talking please during the lecture portion because we are recording them. This week we ended up having to flip things a little bit this week. We're finishing off the week with MapKit and core location. Kevin's doing that, and then next week it'll be the synergy of iCloud and core data, and I'll be doing those.
Okay, cool. And then we have more after that.
Right.
Okay, so today we're going to talk about MapKit and core location, which kind of go hand in hand. So MapKit is a framework that lets you draw maps in your applications. Core location is a framework that allows you to access location-related data. So as a start, we'll talk about core location, just kind of some high-level features that it has. The basic one is to be able to get the device's current location. And together along with that, you can get notifications when the location of the device changes, and you can change the granularity of how often you want to get notifications, how far you have to go before you get a change notification. It also allows you to do not only location monitoring, but region monitoring. So you can set up geofences and get notifications when the device enters or exits that geofence. And an example app that does that is the Reminders app. You can set up a geofence on a location so that way it fires a reminder when you enter or leave a location. And you can actually do that out of the box with the framework. So the first thing we can do is we can get the location. There are two different services that core location provides. One that they call the standard location service. And this is a fully configurable, you can change everything you want about it, how often you get requests, how far you have to go, how zoomed in you have to go. And that's very general purpose. In addition, there's the significant change location service, which is much lower power. Basically just monitors cell tower changes and then sends you a notification when you change cell towers. Because as you can imagine, determining the device's location is a rather expensive operation on the battery because it requires the device to wake up basically all of its radios, and the more radios you have turned on, the faster your battery is going to drain. So the standard location service, if you really need that fine-grained granularity, you can certainly do it, but keep it off as much as possible because the longer you have it on, the more it's going to tax the battery. The significant change service is written in such a way that it minimally uses the radios, so that way it doesn't have to drain the battery so quickly. Oh, that's what I just talked about there. Okay, but yeah, so the idea is Apple's recommendation is whenever possible, use just the significant change location service, because that's done in a very low power way. And if you really need that fine-grained granularity, you can certainly use the standard one with all your configurable properties, but have it off as much as possible because it will kill the battery very quickly. Yes.
How much battery does it take to just say, like, find my location right now?
It depends on how precise you want to be, because there's about 4 different radios that it can use to determine location. There's just the cell tower radio, there's the Wi-Fi radio, there's the GPS radio, and all those different radios. So the more they get turned on, the faster, the more battery you use. Generally speaking, it can depending on how good your coverage is, it can determine the location in less than a second. But if you have an app that is tracking their location, that wants updates on their location, then it's going to leave those radios on, and you'll see a very fast drop off of the battery. Does that answer your question?
It's more of a consequence of polling on how often you set up your granular polling than it is like the actual check.
Yeah, and then the other bit that goes along with that is the more precise you want the measurement to go. It can go down close to the like 10 meter level if you really want to be that precise. But the more precise you want to be, then the more expensive that's going to be on the battery because it's going to take more time doing computation. So if you just want changes on the order of a kilometer, for example, then that's not too expensive because it doesn't have to turn on as many radios if it's not being very precise. Okay, so there's a really simple function class method in CL Location Manager, which is the location, the most common class you're going to use when doing location services from core location. And there's a method, location services enabled, that basically just queries whether or not you can actually whether location services are actually enabled. one issue that Apple has seen, because location is rather a private issue, there's a lot. They've added a lot of checks and balances to make sure that users know if apps are asking for the location. So one global setting they can do is in the Settings app, they can just completely disable location services. So that means that no app can know where they are. And so if that's set off, then this will return no. And even if you try to make a request, it just won't return anything. iOS provides even finer granularity in that you can have it on, but you can disable it on an app-by-app basis for apps that have requested it. So it's possible that the user has disabled access for your app, and so if you get a no from this, then you should make sure that you don't try to ask for the location, because the user, for whatever reason, has chosen not to have location data associated with this application. And that's what I just said. Another case is if the app is in airplane mode, all the radios must be off, so therefore you can't get the location. One interesting thing is if you get a no and you try to start asking for location data, iOS will automatically prop up that automatic dialog that says application name blah 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 wants location information, and then they'll be given a choice of yes or no. And if they enable it, then you can start getting location data. If they disable it, then you just won't get any. Okay, so this is some sample code from Apple that's this is how you start up the standard location service. So assuming this is inside of some class, we have an instance variable. We just want to make sure, if we do the nil check, to make sure that we don't initialize it more than once, so that we only have one of them hanging around. And then we assign ourselves as the delegate for it. And so as we'll see, there's a delegate protocol that just sends a callback methods every time a location-related event happens. And so when an event happens, it will call a method on ourselves. There is a desired so like I said, the standard service, there's a lot of parameters you can configure. One of those is the accuracy level, and there's just a bunch of pound-defined constants for which level of accuracy you want. In this case, we've chosen about a kilometer accuracy. Another parameter that you can configure is what they call the distance filter, which is how far you have to go before a location change notification is fired. So in this case, it won't fire a location change until you've gone half a kilometer. So any location changes that are less than that won't fire notifications. And then once you've set it all up and everything, then you just invoke start updating location on it, and it will set up a background process that kind of just pulls periodically for the device's location, and then if there's a significant change, it will fire a delegate method on the delegate. The significant change service is much simpler. You don't configure any of the properties, and then rather than calling start updating location, you just say start monitoring significant location changes. And so that takes some default values for those configurable properties, and in such a way that it will require very minimal radio usage and minimal battery usage. But other than that, they work exactly the same. You'll still get the same delegate methods, but this just basically sets up some default values for those configuration properties, so that way it minimizes battery usage. And then I think there's a couple other delegate methods, but the most interesting one is Location Manager did update to location from location. So it tells us the current location of the device, that's the new location, and then the old location is the location that core location last reported. So you can, that way, if you want to be able to compute the speed, you can just take the delta between those two locations, and that will tell you how far it's moved since the last location change was fired. Since iOS 4, core location added the ability to do region monitoring. Basically, the idea is that it allows you to specify a circular region centered on some point, and you'll get updates when the user enters or exits that region. And you can look at the documentation to see how to do that. It's pretty straightforward from what I can remember. So these are just some tips directly from Apple to save battery, because again, core location services are battery expensive, so you want to be as battery conservative as you possibly can. If you don't use them, turn them off. Straight up, if you're not using them, turn them off. Whenever you can, use the significant change service. It's much better for the battery. And if you need something more precise than significant change, use the least accurate resolution that is satisfactory, so that way you can turn on as few radios as possible when you actually need to acquire location data. And then the other thing that the other comment they make is if you keep trying and you're not getting more accurate data, then the user probably is just in a bad service location. So you don't want to keep trying again and again and again and again until you get better results, because you just aren't going to get any. So you should turn it off or just be happy with what you get. Okay, so that's location data from core location. Another piece of information that we can get from core location is, assuming that the device has a built-in compass, you can actually get the heading as well. And so there's a magnetometer in the device that allows you to determine the direction of magnetic north. If you want to get true north from that, you also need to know the device's location, so that way it can compute the offset from magnetic north from where it currently is located. Okay, so just like with location data, there's a checker method to say if the heading is available. Basically, this just checks if location services are on and the compass is enabled, or basically if the device has a compass. And so again, this will return yes if the device has a compass, it will return no if it doesn't. Yes?
Is there like really significant change between the two nodes and something?
Between what?
Two nodes and magnetic nodes in, say, 8 years.
Yeah, I mean it's a 14-degree shift. At the pole, it's a 14-degree shift. So the closer to the North Pole, the closer to either pole you get, the more they're going to diverge. But the closer to the equator you get, then the less they're going to diverge.
If you're thinking just in terms of a vector as opposed to using it like a true compass, if you're just talking about like a movement in direction vector, it compensates for that. So that's all compensated for.
Yeah, and it's not hard. Like I said, as long as if you have location, if you have the heading, the magnetic heading, and the location, core location can compute the true north heading for you, so you don't actually have to worry about that. Okay, so here is the code for getting heading updates. Again, it's going to be very much like what you saw with setting up the significant change location. So in addition to the distance, the location information. So here we've set the distance to be a kilometer, and the accuracy to also be a kilometer, and then we start updating the location, and then we can also enable the heading filter. So that's how many degrees, I assume in degrees, not radians. That's how many degrees you have to go before you get an update, and then you just say start updating heading. And again, assuming you've set the delegate, which I didn't do here. But again, it's the same delegate protocol. The method for heading information is location manager did update heading, and then it just passes in the current heading. One other neat feature that core location enables you to do is to do what's called geocoding. And there's two directions in geocoding. One, the idea. Let me stop and motivate this first. The idea is, for computers, location data is much easier to store in latitude and longitude because that's just two numbers. That's really great for computers. It's a pain for people. I don't know the latitude and longitude coordinates of my house, but I know its street address. And so geocoding is the translation of human understandable addresses to computer understandable addresses like latitude and longitude. And there's support for both directions of geocoding in core location. And so it's fairly straightforward to once you have if you have a latitude and longitude to convert it to a street address, I think, or is that, do I have that backwards? Oh no, that's reverse geocoding. Sorry. So forward geocoding. Do I have this? Why do I have these? Okay, I have these backwards. I forgot what order I put these in. Okay, reverse geocoding is taking latitude-longitude coordinates and translating those into human-friendly coordinates. This has been available since iOS 4.1 as a part of MapKit. There's a class, MK Reverse Geocoder, that takes in lat-long and returns human-readable addresses. Since iOS 5, that's been deprecated in favor of CL Geocoder, which belongs to the core location framework. But they both essentially have the same functionality. You give it a coordinate, then you fire off an asynchronous web request, and then eventually that result comes back with human-readable address information. Now what's cool is CL geocoder can do forward geocoding, which is the translation of user-readable addresses to actual Latin long coordinates. So if you want to be able to do that kind of translation, you need to be targeting iOS 5 or later, so that way you can use GL geocoder. And again, if you want more details about this, again, look at the documentation. Both of those classes they're very easy to use from what I can tell. Like I said, you just feed in data and then you get back a response object that you can query. Okay, so that's kind of the high-level basics of the core location framework. So now let's get into the MapKit framework, so that we can actually render maps on the device. So there's a class in MapKit, MKMapView, that's basically a totally functional map view. It's pretty amazing. You just drop in a map view and you have maps in your application without any work. It's, as far as I can tell, it's the same view that the built-in Maps app uses under the hood for kind of just doing the base map. Right now, all the data is fed from Google. Apple recently bought a map agency, so everybody thinks that Apple's going to start feeding their own data for that. And what's kind of cool is straight out of the box, you can zoom and pan and move across the map view just like you would in the basic Maps app. Those are simple properties on the map view that you can set to enable or disable zooming and or panning depending on what you need. So there's a property in MKMapView that they call the coordinate region, and the idea is it basically represents a rectangle, quote unquote, because obviously the globe is a sphere, so a rectangle isn't necessarily actually a rectangle, but it represents a region of the globe, and the idea is it has a lat-long coordinate for its center point, and then kind of a span, which is kind of the idea is it's the number of degrees of latitude. I swear I'm going to have this backwards. Number of degrees of latitude tall and number of degrees longitude wide you want to show around the center point. So it's actually just a simple C struct that contains a location coordinate, which is a lat-long coordinate, and a span structure. And so if you want to change what part of the map is being shown on screen, you just reassign the region property, and then the map view will automatically replace the content that's currently on screen with that region. If you give it a region whose aspect ratio is different from the aspect ratio of the view itself, it will normalize it so that way it appears square, so that way you can't give it squashed maps based on the size of the view. So it will always appear normal in the map, depending on, it does that automatically for you. Okay, one cool thing about the map view is that it has automatic support for showing the user's current location, and there's just a simple property, shows the user location, you set it to yes, and then you get that little blinking blue bubble with the circles coming around it, showing that that's the user's current location. That's done. You can do that automatically. Okay, so let's make our own version of maps. Very simple. Okay, so I have a little bit of setup code already written, so here's our nib. I'm just going to grab a map view, drop it in there. Okay, and just so you guys can see how rather simple this is, I'm just going to run this right out of the box, right here. And with that, we have a map. And we can pan around the map by just clicking and dragging. Can't remember, have I shown you guys before how you can do zoom gestures on the simulator? Okay, anyway, if I haven't, you can hold down the Option key, and you'll get two little dots that you can hover around. By default, they hover around the center, and then you can click and drag like that. If you want them to not be centered around the center, you can move them around, hold the Shift key, and then move them together. Then let go of the Shift key, and then that's the new center point. So that's how you can zoom in the simulator. And so you can see we have basically a fully functional map here. Okay, so let's first let's update that map so that way it shows the user's current location. So I've got a view controller here. It's got an outlet to this map view, so let's hook up that outlet. So we'll just drag that to the map view. Then the rest of the time we'll be in this controller class. So just as a very simple thing, after the view loads, we will show the user's location. So let's start with that. And so you can see that now, since we're actually asking for location data, iOS asks us to confirm that we do in fact want to show location data. And so we'll say yes, so that way we can actually show it. And I've set it to be in New York right now. The simulator isn't able to get the location data from like Wi-Fi assisted. It has to. There's a debug under the debug menu. You can set the location, and so there's a few default ones. There's Apple HQ. There's a few other ones that are moving around, so that way if you want to be able to test movement of your location, and you can also just set a custom lat long, and that's the ones for New York apparently. But if I change it to say Apple, then it will recompute its location, and then there it is over in Cupertino. Which, that's nice, except that it doesn't really... Just showing the user's location won't cause it to automatically like auto-zoom to the right location like you would expect the default Maps app to do. One of the other properties you can configure is the user tracking mode. And so this corresponds pretty exactly to the 3 different modes that the built-in Maps app can do. So it doesn't do anything by default or automatically. There's this follow mode, which means that the map will choose an appropriate zoom level and automatically center around the user's location. There's also follow with heading, so that if the device has heading information enabled, it will automatically spin the map so that way it's facing the same direction that the user is facing. So if we just turn on follow, then the map will automatically zoom and center around where we are in Cupertino. Cool. Yeah, so it's pretty cool how little work it is to have a map in your app and have it be showing you useful information. But there's a lot more that we can do with maps, and what's useful about the MapKit map view is that it allows you to annotate the map, so that way if you want to highlight, say, a bunch of restaurants surrounding the user's location, you can drop a pin for every restaurant around them, and that's what annotations are for. And so a map view, like it is just a view, so it can contain subviews. The problem is subviews stick to the view, but not to the underlying map. So just adding subviews to a map won't cause them, if you pan around, those subviews won't follow the map. So doing subviews isn't going to work for adding annotations to the view, because you want those to stick to a location on the map, not to a position on screen. And so annotations are treated basically like subviews, except that rather than being attached to a XY coordinate on the screen, they're attached to a lat long coordinate in the map. And then as the map moves, the annotation moves. In addition, there's also support for overlays, which are geometric shapes that allow you to show larger geographic regions like states or city boundaries or parks or something. And so you can just define polygons, and it will fill, and you can have it fill in these polygons to determine some region. So here's an example of an annotation. The motivation behind annotations is to highlight specific coordinates on a map and possibly provide information about them. So annotations include an image that's drawn on the map, and then they also have this callout bubble, which has optionally some text and optionally this button on the right that you can tap on, typically for more information. It takes you usually to another page. And these are all configurable with the annotation class. So there's 2 things that you need to put annotations on the map. The first is an annotation object, which is just some object that corresponds to the protocol MK annotation, which is a very simple protocol. It basically just has to store a coordinate. Then that annotation needs to be associated with an annotation view, which is the actual pin or target or whatever, the actual view that gets drawn as part of the map. And so the way annotations are on the map may be slightly unintuitive. The annotation views are not added to the map directly. What you instead is you add annotation objects to the view, and then the map view queries its delegate for a view that goes with that annotation. Does that make sense? So you just you create a bunch of annotations. You put the annotations on the view, on the map, which inherently don't know how to draw themselves. But then, the idea is, as the map needs to be redrawn, it queries its delegate for every single annotation in the map, in the visible region. It asks for a view that corresponds to it, and then you provide a view for it. Okay, so these are taken almost directly from Apple's explanation of how to do this. So there's basically, I think there's 3 or 4 steps. The first thing is to just define an annotation object. So you can either subclass MK point annotation, or you can define your own custom object that conforms to the protocol MK annotation. MK point annotation, as you can probably guess, is just a very basic annotation class that stores a 2-dimensional lat long coordinate. In most cases, that's really all you need, unless you need something really sophisticated. But most of the time, I found that point annotations are all I need. And so you define your own annotation object, or just use MK point annotation. Then you define annotation views. Again, there's a class MK annotation view, and you can subclass it. It's common to use one of the standard ones, like the pin annotation view. So that's actually a pre-built view for you. If you just want to use, if you're just happy using the pins, you can just use a pin. And again, you can also, if you want something more custom, you can subclass MK annotation view, provide your own custom drawing code if you want to be able to do programmatic drawing. You can also just use instances of MK annotation view and set an image property on it. So that way, that's the image that gets used for the annotation. Okay, once you have a definition of your annotation class and your annotation view, then there's a MapView delegate method, MapView view for annotation, that the idea is, given an annotation, return an annotation view that goes with it. And then before you do all that, you just define that method, and then to actually put things on the map, you create a bunch of annotation objects and call add annotation or add annotations on the map, and then those get added to the map view. And as the map view needs to be redrawn, it calls view for annotation on every one of those annotations. Okay, so let's put a single annotation here. So just for the sake of having an easy demo, the annotation I'm going to add is just the user's location. So I'm not going to have the map automatically show me the user's location. I'm going to use core location to get the user's location and then draw an annotation object for that. So let's disable follow mode, so that way we don't automatically get the blue bubble for the user's location. Okay, so what we're going to do is up at the top here, I've put this start standard updates method, which is, again, taken basically from Apple. We're going to... the simulator, unfortunately, doesn't respond to the significant change location service, just because of the way the simulator doesn't move the way regular devices do. So it only responds to the standard service. So I've set an accuracy of 1 kilometer and a distance filter of half a kilometer. And then I just say start updating locations. And so what am I going to do? Oh, actually, there's one other thing I wanted to show you. So let's suppose that we don't want to do this this user tracking mode, and but we still want it to be centered. So ignore the fact that we're doing location services stuff yet. What we can do, or actually no, I'm being really confusing here. Okay, so now let's actually turn on updates, so that way we can get location updates. And just as a starting point, let's just make sure that when we get a location update, that we center around that location. So what we're going to do is we're going to start getting updates, and then in the delegate method for the location manager, we're going to get the CO location coordinate out of the CO location that gets passed in as new location, and then we're going to reassign the maps region to be a region centered around that coordinate, with a span of 1 degree of latitude and longitude. And so now every time we get a location update, we will recenter the map around that location that we just got. Okay, so if we run this, now the map should auto-center. And it's still showing the user's location from before because we still have that enabled, but it's not centering automatically for us. We're actually doing that by hooking into core location updates. And so now if I change the location back to New York City, then it reassigns the map view. Does that make sense? Okay, so now let's, instead of letting the map view automatically show us the location, let's actually put an annotation there in its place. So the way we're going to do this is this this view controller has an instance of MK point annotation that it's going to keep track of. And basically the idea here is every time we get a location update, we're going to update this annotation. We're going to update this annotation's coordinate to be whatever the new coordinate is the core location just reported. And so this is going to be the annotation reference that we're going to attach to the map. And so what we're going to do is we're going to assign ourselves as the delegate for the map view. We are going to initialize that user's location, and we'll give it a... So annotations have a title property. So this is the title that's going to get displayed in the callout bubble when you tap on the annotation. And then let's just add that annotation to the map view. Okay, and remember that we're just adding the annotation to the map, not the annotation view. And so if we want to actually generate a view for that annotation, we're going to have to implement map view for annotation, and then that will pass in an annotation object, and we will return an annotation view for that annotation. And I'm surprised I haven't misspoken yet, because that's a lot of words that I can trip on. Okay, so before I do that, I'm going to make sure that when we get a location update, we update that annotation to have its new coordinate be whatever the coordinate that we just got from core location. And I don't know why I have this twice. Anyway. Okay, so this is sort of some boilerplate code. So if you guys remember when we talked about table views, there's a notion of a reuse queue, so that way you, as you're scrolling, you don't have to keep allocating and initializing cells, because you can just recycle the ones that just got flicked off screen. Apple realized that when you could potentially have 1,000 pins on your map at once, but only 100 of them are in the visible region, and so it would be silly for you to allocate and initialize 1,000 annotation views, and so the map view class has a reuse queue of annotation views, so that way if you just want to recycle one of those views for this new annotation, you can just reuse it too. So this boilerplate code is going to look a lot like the cell for row at index path in a table view, because we're going to try to ask the map view for a reusable annotation view, and if we get one, then great, we can just use that. If we don't get one back, then what we can do is create a new one, and the pin annotation view takes in its input an annotation reference, so that way it knows the coordinate on the map to draw this annotation view, and then it takes the reuse identifier, so that way when you have a queue of reusable identifiers, it knows where reusable views, it knows which queue to put them in. And pin annotation views have 3 different colors that you can use: green, purple, and red. I'm going to use green. One neat property you can add is you can set the animates drop property, which means that when the view gets added to the map, it will drop in from the top and kind of do a neat little animation for it getting added to the view. So because the annotation I want to add is the user's location. One kind of interesting thing is that map views automatically have one instance of MK user location, which is itself an annotation. So every map view already has an annotation for the user's location, and just for the sake of practice, I'm not going to use that one. I'm going to use the one that we're keeping track of and updating using core location. So that's why I have this little trick here to, because otherwise we'll get the user's location twice, and I don't want to drop 2 pins on the user's location. Does anybody have any questions about this code? Okay, so now if we run this, then we get that little drop animation for the pin landing on our location. And you'll notice one thing you'll notice though is that if you change your location, it won't reanimate the drop. It will just switch the map out underneath you.
Can you animate that transition?
Possibly. Ooh, that's a good question. I wonder if let's find out. Let's see if that's an animatable property. It may just be. Sort of. But maybe it looked weird because we were going so far. Maybe if we were going not quite so far, it would... Here, let's... Just as an experiment, let's just shift by 1 degree of longitude. Okay, yeah, so that is actually an animatable property. Cool, I didn't know that. Okay, so you guys have any questions about this code? That's, I think, pretty much all I have today. I'm going to talk a little bit about overlays. I don't have an example for it, but overlays are pretty much exactly the same as annotations, but they're just more complicated because they're polygons rather than points. And so I'll leave it to you to look at the documentation to figure out how to use annotations. But an example use case would be something like putting an outline around states or something. Okay, so here's a few useful resources. For the location awareness guide is just a very general guide about writing an application that's location aware. Then we have just the references for the core location and MapKit frameworks. Yes. So
with the MapKit framework, do you actually have to use a core location framework to get your location, or does MapKit just do that all for you?
Yeah. So if you just want if you just set the shows user location on the map, then you don't need core location at all. MapKit already has its own routines for determining the location. Yes.
For geocoding, why don't you leave it like a latitude that there's nothing there?
That's a good question. It may the documentation might say what it does. It may just try to approximate and find the nearest thing, or it may just return nothing. I haven't tried that though. That's a good question. All right. Any other questions? Okay. That's all I have. Have a good break, you guys.